Hello, everyone, and welcome back. So we're looking at polynomial operations, and we're talking about problem solving with polynomial products. So we've seen how we can work with polynomial products. Now we're going to try and work in real life scenarios, and how do we do this? So I'm going to explain this. I'm going to explain the process that we take through a question. So this question over here says a square garden with a side length of 3x plus 1 meters, right? It contains 2 square flower beds each with a side length of x plus 1 meters. So we're talking about over here, we're given the scenario of someone's garden and we're told, okay, well, we want you to basically recreate this and answer the question. So what we like to do here is draw. Okay, my first thing with questions like this is always to tell you to draw what is going on. So let's draw this together. Over here, we're given a square garden. Okay, so a square garden, let's draw a square as best as possible. Okay, so here's my square garden. I'm going to make it a little bit bigger. Okay, so here's my square garden. And then I'm told that it has a side length of 3x plus 1. Okay, and then they tell us that it contains, okay, so each of these sides is 3x plus 1. We know it's a square, so both of them are equal, so 3x plus 1. And then it says that this square garden contains flower beds. Now, if you've ever seen if you've ever seen gardens, they make kind of flower beds in squares inside. So that's what I'm going to draw inside, okay? So there's a square flower bed. So here's, for instance, a square flower bed. And then they're saying each with a side length of x plus 1. So they said that they made 2, okay? So that's the first one. And I can draw another one in here. Hopefully it's going to look like it's the same size. So x plus 1, we can see that that's the same length on both sides. So x plus 1. All right, on all sides, actually. All right, now it's saying draw a diagram to illustrate. So whether they told us to draw or not, so let's say they jumped directly to B, our goal is always to draw in order to understand what the situation looks like. Okay, so this is her garden, her flower garden, and these are the flower beds. Okay, all right, so let's have a look at then question B. So B says, write and simplify the expression for the area of the grass in the garden. Okay, so they've mentioned earlier that the remainder of the garden is grass. So all of this stuff over here, this is all grass. Okay, everything that is not in this flower bed is all grass. Okay, so now they're asking us find the area of this flower bed, or at least find an expression for the area of this flower bed. Sorry, for this grass. Okay, so what we notice is over here is that I have this entire garden. I can make its area by multiplying this squared, right? This by this basically, so this squared. And then I can do the same for the inside. To get this area, I can do this squared, and as well as for this. Now, what I notice is that if I were to take away these two from the entire area of the bigger square, I end up with the area of this grass, right? So that's what we want to do together here. So let's do it over here. So it says, write the expression for the area of the grass. Well, the area of the entire garden is 3x. So area of garden, okay, is 3x plus 1 squared. And the area of flower bed is x plus 1 squared, but there are 2 of them. So it's 2 multiplied by x plus 1 squared. Okay, so what do I need to do here? Well, I need to expand both of these in order to see what we need to do in terms of finding the area of the grass. So over here, if I expand this, remember we did in part one of multiplying polynomials, we said that when I have a sum squared, basically the first term is going to be this term squared. So that's going to be 3x all squared. The second term is going to be 2 multiplied by both of these terms. So 2 multiplied by 3x multiplied by 1. And the last term, since it's addition, all of them are addition. Since it's the last, and then the last term is 1 all squared. All right, so let's simplify this. So we're going to get 9x squared plus, remember, with exponents, we do power of product like that. I give each of these the square. So 3 squared, that's 9. X squared is x squared. 2 multiplied by 3x, I get 6x multiplied by 1 is just 6x as well, plus 1. Okay, so this is the area of the garden over here. This is the area of my garden. Now let's have a look at the area of each of those flower beds inside. So if I were to simplify this, right, to get the area of the flower bed of one flower bed, of the 2 flower beds, I just go 2 multiplied by x plus 1 all squared. And what happens here is same thing. I keep this 2 and I expand this. And this is again the square of a sum. So over here, I'm going to go first term squared plus 2 multiplied by first term multiplied by second term plus 1, the second term squared. Okay. All right, so let's simplify this. We'll have 2x squared plus 2x plus 1. And remember, when we had a monomial like this, when we had a monomial and then a trinomial or a polynomial, I just expanded by distributing this 2 to all of them. So I have 2 multiplied by x squared, that's 2x squared. 2 multiplied by 2x, that's 4x. 2 multiplied by 1, that's 2. Okay, so now what were we being asked? We were asked, what is the area of this grass over here? Okay, so the one covered in baby blue or now green. So what we needed to do is we needed to get this area and subtract this area over here and this area. So now we have 9x squared plus 6x plus 1. And remember, we want to subtract from it the area of the flower bed. So what we're going to do is we're going to say subtract 2x squared plus 4x plus 2. Okay, we're subtracting this entire thing. So then I'm going to go 9x squared minus 2x squared. That's 7x squared. 6x minus 4x, that's 2x. And 1 minus 2, that's negative 1. Okay, so what is the area of the grass? Well, the area of the grass is equal to this over here. Okay, so let's review our steps and how we cover this. So our first step is to always draw. You always want to draw the situation, because when I drew it, I was able to recognize that the missing area for the grass is basically the entire thing subtracting what's taken away from the inside. Okay. All right. So we want to first draw our situation. Whenever doing any word problem, if you can draw it, you draw. And then our second step is to basically find polynomials used and expand when necessary. Okay, so in our case, we had a situation necessary. So we had a situation where we needed to expand. And why did I expand? Is because if I tried to do 3x plus 1 squared minus 2x plus 1 squared, well, I don't know what the like terms are. I can't go, oh, that's 3x minus x, 1 minus 1, right? I won't get the right answer. And you're going to see that that's true. And you can try this as extra practice. You can't do that. You need to, when you want to subtract two polynomials, they have to be in their expanded form. Okay, they have to be in this expanded or standard form. Okay. All right. So expand when necessary, and then answer the question. So once I've worked with my polynomials and I've put them in a form that I needed, I need to answer the question. I need to see what is the question asking, because I don't want to just like leave it at expanded form. Okay, what does that even mean for us? No, what's useful here is that they ask for the remainder of the graph. So we already developed our plan, right? So that's kind of over here, and then develop plan. Okay, like what do we need to find? Okay, so unknowns basically. So based on what you need to find, and then answer your question by over here, we did this subtraction. So we subtracted our polynomials. Okay. All right, everyone, that's really it for developing a plan for problem solving. You draw, you figure out what am I trying to find, and then you expand your polynomials when necessary, and you answer the question by either subtracting or adding, whatever the situation is, it really depends. So join me in example videos where we're going to see different forms of questions for problem solving polynomial products, and you'll get a better sense of how to work with polynomial products in real life scenarios. Okay. All right. I'll see you there. Bye, everyone.